Here we have metaperchlorobenzoic acid. In short, it is known as MCPBA. This is the structure of metaperchlorobenzoic acid. Okay. It is prepared from metachlorobenzoic acid. It is a peroxy oxidizing agent specifically used for the epoxidation of alkenes. It's a colorless crystalline solid. Commercially, it is available with 80% of per acid, and rest is the metachlorobenzoic acid. As I told you, is prepared by alkaline oxidation of metachlorobenzoic chloride with H2O2. Now let's see the reactivity or some reactions of metachlorobenzoic acid, particularly the epoxidation of alkenes. The first example, where we have one propene, it's get epoxidized with the help of metachlorobenzoic acid, or in short we can say MCPBA. Dichloromethane is used as a solvent and the reaction is carried out under reflux condition. Similarly, cyclohexene can be epoxidized and we get cyclohexene epoxide as a product. Here, the stereochemistry shows that the epoxide is formed either from the top phase or from the bottom phase. So, depending upon the substituent on this polyphenic carbon, we'll get the product, but the epoxidation is a syn addition process. So here in this second example, we can say this epoxidation is stereospecific. If we start with the cis isomer of alkene, it will give the cis epoxide, and if we start with the trans isomer of an alkene, it will give trans epoxide. So in short, we know that the epoxidation is a stereospecific reaction, and when it is carried out using MCPBA, we'll get the respective product. So MCPBA, it is used for the epoxidation of simple alkenes, in which the carbon-carbon double bond get epoxidized, and this is a stereospecific reaction. Cis alkene will give cis epoxide, whereas trans alkene will give trans epoxide. Now let's discuss some selectivity during the epoxidation reaction using metachlorobenzoic acid. For example, in this reactant, we have two polyphenic double bonds. Here, on this left hand side, it is a di-substituted alkene, whereas this right hand side double bond is a tetra-substituted alkene. So it has been observed that when the epoxidation takes place, it prefers the electron donating groups attached to the alkene. So a highly substituted alkene undergo epoxidation, and the product form in this reaction is like this. We can also write the another isomer of this, where the oxygen or epoxide ring is above and these methyls are going back. When we have a substrate in which an isolated double bond and conjugated double bonds, in such cases, the regioselectivity in epoxidation is observed. The epoxidation of isolated double bond takes place preferably over the conjugated double bonds.